people have been sending me questions, and then everybody who's listening can put questions also in the question log. But maybe two of my own questions up front, if I may. The last time we had you on Code Rage, Bjarne, you were at Texas A&M teaching and doing research. Now you're at Morgan Stanley in New York City. Can you tell us all a little bit about what you're doing these days?
Some of it is more sort of constant than you would have thought. I still look after the standards committee. I'm very busy trying to get ready to a meeting next week in Urbana-Champaign. And so I'm doing the standards, I'm doing the C++ work as ever. I'm still associated with Texas A&M, and I'm also now a visiting professor at Columbia, where I go basically every week. And one of the reasons I'm at Morgan Stanley is that they have interesting computer problems basically beyond the dreams of practical computer scientists. I mean, what they're doing in distributed systems, in networking, in reliability, in large code bases, rapid development, solid development, performance, is just very interesting. And so it's nice to be back in industry again, and it's nice to be up in New York near my family and grandchildren again. So I moved. I've been up here for 10 months now, and probably would have liked Texas winter, but well, I'll get a New York one.
Excellent. Now, one other question from me is, now that C++ 14 standard is approved and delivered on schedule, and you had a list a little bit in the keynote, what's next over the next couple standard releases for the C++ language?
Oh dear, this is hard to say. You have to remember that the C++ Standards Committee works with consensus. So if you can't get people sort of basically to agree, you get nothing. And by consensus, we mean maybe 90% people agreeing. And the reason we work so hard for such a high barrier is that we don't really want people to fracture off and make their own language and such. We want something that can have stability and that we can agree to. It takes a bit longer usually, but it works. We've found a way of working harder and faster now and delivering on time. So C++ 17 is likely to happen on time. It is not absolutely certain what will be in C++ 17, because our plan is that the train leaves the station in 17, and if you don't make your proposal, if you don't get consensus, if you don't get the details right, you'll have to wait till 20. But that's 3 years, not the usual decade for ISO standards. So we're aiming at making a lot of improvements to the concurrency models. We want higher level concurrency because threads and locks are about the worst way of writing concurrent programs from the point of view of somebody using concurrency. They're machine level concepts, just like in the old days we wrote in terms of registers and memories and things like that. So we want to get higher up. We want task level concurrency. We want the futures to work better. People are working on transactional memory. They're working on SIMD vectors, work stealing, all kinds of stuff like that. So my guess is that C++ 17 will see a variety of more user-friendly and better performing concurrency models. That's probably the biggest thing there. We should see concepts in the language, not just as a technical specification, and I hope we will actually see a concept-based standard library in 17. We've of course already started on that work because the way we started the new effort with concept was to build a library and then see what we needed to express that library well. So the Palo Alto TM is a good start. And Andrew Sutton has gone much further than that, and he has in his repository, look up for Sutton and origin, and you can find it. He has a very nice start of the concept library work. There's people working on modules to speed up compilation. That's largely Apple, Google, and Microsoft. And we have people working on quite a lot of other features. If you go to the WG21 site, you can find the list of papers for the meeting next week. And we have a shocking 120 papers, which is a new record in all the time C++ has been developing. We've never had so many submissions, and some of them are really quite good.
You know, and I like that section of your keynote when you talked about doing things in libraries first and not necessarily in language. We have those conversations internally all the time about what should stay in the libraries versus what goes in the language. So that was really cool. Ernesto asks, how do you feel about the evolution of C++ since it was first implemented? Has this evolution been positive in your mind?
Definitely positive. C++ is a tool. It was always conceived as a tool. I had my first user, not testing, but for actually delivering something after 6 months. And after that, I have had developed things under constraints of compatibility. You don't want to piss your users off. And you want to improve things. And sometimes to improve things, you need research, you need experience, you need to learn from other communities. And there is no comparison between C++ in 85 and C++ 14. C++ 14 is by far the better tool. And I'm just a little bit sad that we didn't get concepts shipped together with the rest of it, but it'll be there by the end of the year in various places. You can get a very good experimental version now from Andrew Sutton. So we're looking for it as a tool, and it's much better now. If you go back to my very first paper on C with classes, that was before we even got the name C++, you'll see that I talk about data abstraction, basically encapsulation and interfaces. You will see me talk about object-oriented programming in terms of class hierarchies and virtual functions, and you'll see me talking about generic programming. And in all of those areas, C++ 14 is a better tool.
I also liked the discussions you had about templates and then concepts. Now, several attendees have asked if you could go back and change C++ in some way, what would you like to change, if anything?
I always get this question. Of course, I can't go back. I don't have a time machine. And secondly, if I had a time machine, there are things I would like today that just couldn't have been done 20 years ago. So, yeah, I would have liked a nicer syntax, especially for the Clarity syntax is just too complicated and such. So I had to go back and talk to Dennis in 74 or so, if I had my time machine. If I had my time machine, I think I could have dropped a specification of concepts on my desk in about 86, and I think we could have done a better job of templates. If I had known that then, it would have been simpler than what we have now. But you can't go back and take things away. I mean, if you don't have a time machine, you can't just cut things away, because people want all kinds of new features, all kinds of extensions, and they all complain that the language is too big and complicated. They want it much smaller, much simpler, and they want 2 more features. And by the way, I'm not supposed to break their code. And there's no real solution to this. We've tried to deprecate features, declare that they will not be supported in the future. People do not want their features, even if they hate them, they don't want them to go away, because then they have to go and rewrite the old code, And the old ugly code that uses the obscure and bad features are exactly the code that's hard to remove, because that's the stuff that's too complicated and badly written. So think of it, stability is a feature and it's a pain in the neck, but it's more a pain in the neck for the standards committee than it is for the average user. Just try and evolve your code out of the dark areas.
No, I loved a bunch of the quotable quotes that you had. Bugs hide in the dark corners, loud, heavy, odd, and different, drowning syntax, a lambda magic. All those were just absolutely wonderful. Jack asks a question, not that there's anything holding C++ back. It's being used for so many different things in so many different ways across the planet and even off planet, as we know. But do you think there's that one thing that could be an issue is the lack of a standardized binary interface for compilers to use?
There are two areas that's holding C++ back badly, and they're very hard to deal with, or we would have handled them by now. The first one is the lack of the binary defined binary format across compilers. If you have a monopoly, if you have one compiler, if you have one owner of a language, you don't have that problem, very much at least. But, well, I've seen incompatible Java versions, but basically it's a problem that you have when you have several platforms and several platform suppliers. And the suppliers, by and large, want to be compatible with their own previous version. Some people break compatibility very often, have ways of dealing with them. Microsoft is one such example. Others try to keep stable over decades. GNU is one such example. And getting them to agree to break incompatibility with all their old code, and each of them has 1 billion or more lines of code they're supporting, having them to break that is really, really hard and agree to a standard. There was some attempts. There was the Itanium idea that could have flown but didn't. There's now work on the 64-bit layouts on the 86 architectures, but it's really, really hard. It's not something that the standards committee can deal with, because each owner of a platform, each owner of a development platform has their own standards and they don't want to mess with them. We bring it up again and again and we don't make progress. There's just a lot of inertia here that's difficult. And you can raise the level of a language so that the basic hardware goes away and you work in some kind of virtual world, and that's just not what C++ is. The great strength of C++, the great differentiator for C++ compared to other languages, is that we actually use the real hardware. And the problem is that when you use the real hardware, all kinds of interesting things become visible to the compiler writer, such as how many registers are there, how do you access atomic operations, what are the layout of objects, and how long does it take to dereference a pointer. The other problem that's holding C++ back is the lack of a standard GUI. I mean, we have GUIs GUI toolsets that are used more than most languages, but there's not one standard for everybody. So if you want to do GUI work, you have a choice, and quite often people don't want a choice, they want an answer. And we can't make any progress there because back in the late 80s, early 90s, every vendor thought this was the way they were going to lock in their user base. And that's an early version of what we're seeing today when, say, Apple and the Java guys and the Microsoft guys and the GNU guys are trying to lock in their users with either proprietary private languages or libraries that doesn't compile with other people's compilers. We are in the domain of not public open standards, but of commercial decisions.
And Roger and Andrew, there's sort of two things they put in the question log, and I'll combine them together in a sense. Andrew was saying as you're teaching at what level, and then Roger was asking for any advice on how to encourage young computer graduates to get the principles of good programming and to really understand that.
I was sort of a full-time academic for 11 years, and there I taught freshmen, I taught other undergraduate courses, I taught graduate courses at various levels. And the thing that's most relevant here probably is two kinds of courses I was teaching. One was the freshman programming course for people who basically never had programmed before. Or if they had learned some programming that I thought wasn't quite up to snuff because the US high school curriculum for computing is pretty vague. So I tried to teach and found that the textbooks wasn't really all that great for teaching people programming, and eventually I came up with a course and a book called Programming, Principles and Practice Using C++. And you can find it on some of these slides, you can find it on the homepage, you can find it at Amazon and so on. And that's basically for beginners and for people who want to get into C++ programming from a very different background. And it's a fairly conventional teaching thing, but with a much heavier emphasis on how to get code right. How do you do testing? How do you write a function interface so that you can test the arguments? How do you write loops so that you don't go off the end? And it uses C++ features from day one, strings and vectors and things like that. It gets a little bit of graphics in because today's students don't believe they're doing anything real unless they can do graphics, and also a bit of algorithms and the STL. You can learn all of that in C++ in 3 months if you are taking 4 courses a year and you are sort of reasonably good student. Then the second half of the book is more stuff that you need for practical purposes, depending on what you're doing, things like numerics or regular expression matching, text manipulation in general, something to do with embedded systems programming, things like that. So that's where I recommend people to look if they're starting with programming. If you're already a programmer and you feel that maybe your view of C++ is not quite up to date, and I would say that's the case for most programmers. Either they learned C++ a long time ago, or they learned Java or C# or something, and they have a view of C++ that may very well be what their teachers first saw in '85 or thereabouts and haven't noticed a change. So if you're in that kind of category, I wrote that little book I recommended in my talk, A Tour of C++, which started out as the beginning of a course I was giving to beginning graduate students at Texas A&M, people coming in from all over the world and therefore have very different views of the world and different views of what programming is, and also for senior undergrads that suddenly realized that they had to get a job in the real world, and it would be a good idea to know C++ a little bit better. So there I take a very quick tour of basically everything, language and libraries, from a modern perspective, and says, well, this is what C++ is today. And if you need to know that, you can do it, as I said, in a plane journey. I've done it on a transcontinental flight. You can read every word in that time. If you want to know more, there's of course the C++ programming language and a lot of other stuff. But if you want that initial overview, the initial view of what modern C++ is, the tour of C++ is probably a good start.
Yeah, no, I remember 180 pages. I also remember that some of the early chapters appeared on the ISO C++ page originally, but so everybody should go to the ISO CPP.org page. There's an enormous amount of information and links there for everyone. Let's see. Rob asked, you speak about code rejuvenation or modernization and that developers should bring their old code up to new C++ standards. What do you think are some of the obstacles? You mentioned sometimes tools managers or just lack of wanting to change. Any advice for developers?
If you touch a piece of old code, there's a risk that you break it. The only reason that code would be worth touching is that it's still in use, therefore there's something you could break. Furthermore, old code tends to be ugly. It's easy to make code uglier, it's harder to make it more beautiful. So old code will be ugly. The people that wrote it probably aren't there anymore, or they would have sort of gradually improved it. And furthermore, old code tends not to have good unit tests or regression tests, so it's dangerous to touch it. This is really hard. Furthermore, it tends to be written in a complicated, convoluted style. I mean, spaghetti of pointers and things like that. That makes it hard to understand. That's why it's hard to do, and that is why I really want static analysis tools to help us, because I think a good programmer shouldn't really be condemned to clean up such messes that was made 10, 20 years ago. On the other hand, I have worked on such tools. I know they can be built, and I know people are working on them on an industrial scale. So one thing I would like to do is to have a tool that goes around and looks at my loops and see whether it's a loop that will fit the modern range for loop style. And it'll go in, it'll look to see whether you are touching more than one element for each iteration. It'll see whether you are passing pointers or references out of the loop so that there might be strange things happening elsewhere. It'll look to see whether you have done silly things with the with the loop variable. And if the answers to all of these questions are no, it can just safely transform the program into something that's a modern range for loop, like the example in the talk. And that would simplify a lot of code. And the code that wasn't simplified is the one that a human should look at to see whether it can be improved. And there are many areas like that. I really think we could get rid of most arrays as opposed to the standard array type or the standard vector type. I think we could get a lot of complicated control structures turned into algorithms and things like that. But we need to help. I believe, especially in the Clang tool world, there's a lot of work going on there, so there's hope.
And I know that you spend time on the language, but you're also on the ISO committee. Greg asks, what else do you or the ISO C++ committee see coming along for the standard C++ library?
There's a lot going on in the library, mostly in the concurrency area, and that's an overlap between library and language. We have several proposals for coroutines. So if you want a lower level, more close to the language, much faster forms of concurrency without, but cooperative and such, we're going to get something like that. In other words, we're going to get back to what we had in C++ in the 80s, where I used tasks, which were basically a form of coroutines to run faster than anybody else. We'll probably get work stealing. We'll probably get SIMD vectors, which is very important because of the way the machine architectures are working out. Intel and IBM are pushing transactional memory so that you don't have to write logs explicitly. So there's a whole area there. Then we're going to discuss things like range libraries, so that we can do things like sort V, as I wanted in my talk. and as a lot of us has, but it's not in the standard. We're working on that. And then there's things like the file system things, so we can talk about files and directories and such. That's already approved now. We'll get concepts, so the concept version of the library should come in, and that'll help. For instance, the new range library that is being built already is specified in terms of concepts, because that's one way of keeping you straight when you design new things. We're going to get little things like string view, which allows easier string manipulation. We're going to get an optional type. I think variant is already in. So there's going to be some foundational stuff. I can't keep track of all of this. There's just too much of it. And I try to take an interest, but you can go over to isocpp.org, click on standards, and find the list of working groups going on there. There's even some 2D graphics being worked on now. So maybe if we can't get the whole GUI system, at least we can get some decent output. And databases, unfortunately, is inactive. You see, this is a standards committee out of volunteers with no monetary resources really. So unless there's a critical mass of people who want something done, it will not be done. So don't just complain. The obvious answer from the committee is you're complaining, what are you contributing? So if you have something to contribute, if you think there's not enough there now, well, maybe you can do something about it. There's also been repeated attempts and rumors and such to get a much larger thing going about libraries. That is, there's a lot of commercial organizations putting out open source software. Adobe has been doing it a lot. Google does it a fair bit. Facebook. What was it? Well, anyway, there's a lot of Dropbox. There's a lot of that, but it's not in one place. There's no rating system for it. There's no checks or interoperability. We need somebody, something, some organization that will coordinate all of this stuff that's available out there. And this is industrial quality stuff. Like Google protocol buffers is serious software being used in serious ways in lots and lots of places. And a lot of people just don't know about it. They don't know where to find it. They don't know how to install it. We can do better.
Gregor was asking, he has some clients that are still using C, and he's wondering if you have any advice for helping him convince them that it's time to move to modern C++.
There are people who think that because things are complicated and low level, it must be faster. And there's people who think that if there's fewer pages in the manual, it must be easier to do development. This is just completely wrong. It's not an easy thing to do because people want to believe in some of that old stuff, and it's hard to convince them to learn something new. And one of the problems I think is most fundamental is that they believe myths about C++ in particular that get them to think they couldn't possibly want to learn it because there couldn't possibly be any advantage to it. A typical one is that people believe that you should use C++ if you want to write object-oriented programming. That is, if you want all of your code to be classes with virtual functions. And people look at their code and they say, but my code doesn't fit into huge hierarchies, so I don't need C++. That so is wrong, because a lot of C++ is not organizing things into hierarchies. The whole generic programming stuff is not that way. Furthermore, a lot of the facilities in C++, like simple for loop, like better type checking, like const expert functions and such, works even if you're writing in a C style of programming. You can just do it with better support, better compile time support, better code generation. I suspect that the best way to say is, why could you write a piece of program better in C than C++? I've never found a good answer to that, except not knowing C++ or not having a C++ compiler. If you use just a few of the simple C++ facilities, your code will run faster in C++. But it's very, very hard. I just wrote something which I'm going to serialize on ISO CPPorg as soon as I figure out how to post, which is called myth. And I'm putting up 5 popular myths, and I'm going to show why I think they're myths. And that might be helpful.
Excellent. I know Christina was talking and asked, she was talking about all the internet trolls that are out there saying C++ is way too large and complex and getting larger and more complex. And, you always advise everyone, use the parts that you need to use of any language and any set of libraries. Do you have other things to say to all those trolls in response to their constant yammering?
Sure. Complexity don't actually go away very often. We have the complexity that's inherent in a system, in a problem. We can't do much about that, except hide some of it away. There's a complexity that comes from the way we express our solutions. That's what I call accidental complexity. And if you have a very simple programming language like assembler, there is lots and lots of accidental complexity, like you have to think about which registers you use. If you go one level up and you get to something like C, there is a lot of accidental complexity because you have to think in terms of integers and structs and pointers and such. You don't have higher level abstractions. If you go to C++, the incidental complexity, the complexity you have to deal with directly in your application, goes down because it's been pushed into the language. So when you use a vector and you do a pushback to add an element to it, that just happens, and it happens well. If you want to do that in C, you have to write your own code and use realloc and test for overflows and all kinds of things like that. Your code gets bigger, harder to maintain, more complicated, because the complexity is in the application, where in C++ it's in the standard library in that particular case. And so you have your choice. Where do you want that complexity? Increasing a data structure is not something that hardware does. It's something that the language can help you do, or it can let you do for yourself. Then people tend to underestimate that, and they underestimate the maintenance burden, and they underestimate the complexity of writing stuff directly in C, and they underestimate the number of bugs they create. I guess a lot of us are programmers because we like to write code, and we don't particularly like to read manuals or tutorials, but we have to get more professional, and that means spending more time with the learning, with the tutorials, with the manuals, and less for writing reams of ugly, simple-minded code.
And I'm going to put up on the screen this is the C++ isocpp.org site, HTTPS, iso.cpp.org, and you'll find all sorts of great stuff: news, events, articles, blogs, videos on demand, tutorials. It's a great site with all sorts of wonderful stuff that the team that works not only on the standard, but Herb Sutter and others that keep this site going, and all the community members that are contributing. It's just wonderful. You can also follow all the RSS feeds as well.
Yeah. 2 comments here. One, you even get embarrassment from the dark ages. Somebody found one of the very first documents in the C++ standards effort by me and Andy Koenig and put it up from '89. The other thing is, maybe you'd like to put up the C++ Foundation page. This site is run by something called the C++ Foundation, which is basically an industry a group of industry people that decided to push C++ a bit. And there's some interesting names up there, and you'll notice the spread over the industry.
Absolutely, it's a great place with a lot of people doing things, and of course all of you as the directors and officers guiding it is really wonderful as well. And for me, it's a great resource.
And it's important. We're not fighting. A lot of these organizations are commercial competitors, but the underlying thing on all of these corporations, down deep in their systems, they depend critically on C++. Have decided that's not the area where they'll fight.
We want the language moved forward, so absolutely. So Ian is asking, when you're writing code, what sort of tools do you use? And I know you try C++ things on multiple tools and using different compilers as well, right?
In my personal work, I'm a very low tool user because I tend to focus on portability, and I tend to focus on sort of fairly simple examples. I do a lot of experimental code, a lot of bleeding edge code, and you don't want that obscured by complicated tools. Sort of professionally, I use whatever is used in an organization, and that's not indicative of anything. I'm not a great user of debuggers, for instance. I don't mind a helpful editor as long as it doesn't get too helpful, but I'm quite capable of developing using just a text editor. I really like static analysis tools. I mean, it started out with lint, and the compiler is now what would have been a static analysis tool 20 years ago. It's getting better at that, and so I really like anything that can help me to tell me when my code is ugly, complicated, stupid, things like that. I have no specific recommendations for, say, test generators, test suite, unit test frameworks, things like that, or build systems. I'm fairly agnostic about those things. You need them, but I don't have an absolute favorite.
I've put up just a reminder for everybody, a tour of C++. There's just the cover. You can go and grab it either in paper form or as an ebook.
Personally, I prefer paper because unless you're reading it on a big screen, you don't actually get it very well. I find that textbooks doesn't actually work on the size of tablets and cell phones that people use for reading, and then they get very annoyed and they go on the web and says this book is unreadable. They don't say what it's unreadable on, but it's usually a screen that's far smaller than I imagined. I like a book that's open so I can see 2 pages at a time, and you'll find that my books have been fairly carefully written and organized so that works. So for instance, when a code example can't fit on 1 page, you will find that it tends to break over facing pages. And that kind of stuff you just simply can't get on the average small screen. Big screens are fine.
And then finally, I put up your homepage at stroustrup.com. I think last time we had you on, there was a picture we had of you in your office at Texas A&M, and you were sitting in your office at Texas A&M a couple years ago, which was fun. Bjarne, I want to thank you very much for spending this time with all of us. It's always a pleasure to have a few minutes to talk with you.
Okay, thanks. It was a pleasure. Bye.